Okay, let's go ahead and get started. Sounds like y'all all had a very good weekend.
Oh yeah. Good
Very
weekend.
enjoyable.
Good weekend.
And hopefully you all are all well rested. So today we're going to finish up on inheritance, and then we're going to talk about, finish up on inheritance. Someone remind me to go over enums, because I don't think I've done that this time or this semester.
I thought we talked about enums.
We talked about them briefly, but I want to go into a little more detail to help everyone understand. I talked about them briefly for the lab, and then I realized I never taught y'all enums. So
You said that they're an object.
there's a difference between explaining it and showcasing it. Let me showcase it so people understand it better. If I go out and I write the code and everyone follows, you'll seem to learn a lot better than if I just talk about it on the board. So I can do that real quick. It won't take too long. And then we'll hopefully talk about the midterm. And then we'll jump back into, chapter 9, which is having to do with composition instead of inheritance. We'll talk in more detail about when or how you want to compose with aggregations or associations. And then hopefully if we have time, we'll start talking a little bit about iterators and lists, because they'll be on your midterm. But let's start with the quiz. Let's see, why would a child class override one or more of the methods of its parent class?
Because it doesn't need.
Think about the lab I just assigned.
Like the shape class listed just returns the height and width, but what are the shapes? It needs something extra with like.
So we have,
Or the areas
So-
are different.
Yeah.
right, so with parent, with shape, you don't really know what the area is, but it's going to be different for a rectangle, different for a circle, different for a right triangle.
Yeah.
So in other words, the class is going to prefer its own definition of a method in favor of a definition provided by its parent. So it overrides or redefines the parent's definition with its own. It's basically changing the behavior to its own behavior. So what's the role of an abstract class? Or what's the role of an interface? Maybe a better question.
It's like the open close principle, which helps you building.
Jumping head to solid, but that's good.
It's like the methods that you want.
So it's a way to enforce certain methods have to exist in your code.
Yes.
Yeah, it forces you to write certain methods. The idea represents a general concept. Common characteristics and signatures can be defined abstract. So anyone that inherits have to derive from it, or AKA either they get the functions or they have to override certain functions. Are all members of a parent class inherited by the child?
You mean all members?
Oh, so a class can have attributes and methods. So it can have data members. Like our Pokemon had hit points.
If it's protected, it doesn't. But if it's anything else, then it does, right?
So the answer is yes. Everything is actually inherited. Although the private member would not have visibility in the child class. So, and if I draw a picture, I think this will make perfect sense. I'll find a marker. Marker.
You always use some markers.
Here's a marker.
What the heck?
And now I need an eraser. Oh, there's an eraser. Okay, good. I'm up on the board. So, let's go with good old, this marker's done.
Yeah, 3 more up there.
See if I can hit it.
There's one over
Oh! Kobe!
Should have brought in pro NBA player.
Yeah, would have made more money.
Yeah.
All right. Yeah, well, that's much better. So a mammal might have, what's mammal?
Babies.
Warm-blooded.
Warm-blooded.
They might have.
I'm trying to think. What? Fur. Okay.
That's not true. Bats don't have fur.
Yes, they do.
Do they?
All mammals have. A hair is the technical term. So we'll go in, hair, or I'll put, actually we'll do, in hair count. And then if that is private in hair count, and then you have dog extends mammal. Does dog have M hair count?
Yes.
But can dog access M hair count? No. What is happening in memory is when you allocate a dog, you go, let me write the,
Always allocate the dogs.
yes, we're going to allocate or instantiate a dog object. What's happening first, in all technicality, is it first makes your mammal object, which has int M hair count, plus whatever else is in the mammal, and then it appends whatever might be a dog, like we'll just say void bark. So then you would have, right here it'd be dog, it appends bark to it. And then that's the whole object right there. Okay? So when you're inheriting like this, everything is there in dog, because dog is actually going to point to right here at the beginning where mammal begins, and then the compiler essentially appends everything else in memory. Okay. Ooh, clear. How can the final modifier be used to restrict inheritance?
Final can be changed. So
Right.
if you would put that into one,
Into
the parent,
the parent,
then the child class can't change it.
can't change it or override it. So if the mammal up here had something final, make sound or whatnot, move, then dog wouldn't be able to do it. But it's basically you apply it to a particular method, which keeps that method from being overridden by the child. You can also apply it to the entire class, which keeps that class from being extended at all. All right.
Children.
Silly children. All right. Why are when it starts with why, it's difficult. Why are interfaces, protocols, and abstract classes powerful mechanisms for code reuse? I think I put up the books reason here, but there's actually a ton of reasons.
Read aloud. YouTube.
Well, one of them, organization.
Organization, that's a good one.
But specifically for reuse, if you've got a parent class, you don't have to retype all of those methods in your child class.
If you have a parent class, you don't have, right.
Yeah.
So,
So you're saving a lot of time not typing extra code.
right, so saving time. How about protocols? Have we talked about protocols much? So protocols is basically how do two entities communicate. For example, how does your mouse interact with your computer? It's over the USB protocol. One computer communicates to another, it's
Do you know-
Ethernet, TCP.
You know one that it works one way, or like you program it and it works sending to one way. If you change one class, you'll keep that connection. You know it'll work. Yeah, that.
All right. So what the book is trying to get here, and I think it's important to at least touch base on, is all these mechanisms provide a contract between two bodies of some sort. You're basically sitting down and writing out how are you going to interact with one another. And as long as everyone adheres to the contract, everyone should be good. And then why would interfaces / abstract classes be preferred over copy and paste? Reduces your code, which means,
But you could
I mean, that's good. That's a good point. Less code, which makes it easier to read.
You could accidentally not copy everything.
You could accidentally not copy everything. More important, think of maintenance down the road. And there's a bug in your code.
So if you've got a bug in your code, you only have to change that class. You
Right.
have to change everything.
Yeah, the biggest thing here is maintenance. You only have to change or fix a bug in one spot. Hopefully, if you do it right. as opposed to every place you just copied and paste. Because when you're trying to fix things, everyone's looking for the one-line fix. So, all right. Any questions on that? Quiz. All right, great. So reading, going to chapter 10, I'm just going to thought process, and that'll be the last chapter for the midterm from that book. And then Coronado, chapter 7, we're skipping a lot, but I think it's important to look at collections because it really drives everything we just learned home and shows you why it's all important. But yeah, section 7s 1 and 2, which will talk about collections and iterators, which we may get to today. All right. So let me pause here.